Good morning everyone, how are we doing? I hope we are well. I have a question for you. Have you ever tried Rolos before? In my opinion, they're really underrated chocolate. They're really nice, and I want you to imagine what shape do Rolos come in. So if you haven't had Rolos before, they look a bit like this. Do you know the name of this type of shape? So this type of shape, you can almost imagine it as a cone with the top just chopped off. So, if we take a cone or a pyramid and we slice the top off, we're left with what we call a frustum. So, if you look at my animation now, if I take this cone, if I just make a little slice here, remove it, I have that kind of Rolo shape, but the mathematical name for it is a frustum. And the same thing applies for a pyramid. So, cones or pyramids, we would both call them this. So, I'm going to slice it here horizontally, remove the top, and I'm left with this bottom portion of the shape. In today's lesson, we're going to be learning how to find the volume of these types of shapes, and there's actually a very easy trick that we can use. So to find the volume of a frustum, all we do, imagine the top and subtract the smaller shape from the larger shape. So let me give you an example. Let's imagine we're trying to find the volume of this shape. So this Rolo looking shape, all I'm going to do, I'm going to imagine that it was a full-on cone, right? So I'm going to imagine that dotted line completes that 3D shape. Well, how would I find the volume of this whole shape? Well, to find the volume of a cone, I take the base area and multiply it by the height and then divide it by 3. Because a cone is just a third of a cylinder with the same dimensions. So that's the formula that I can use. So what would this large cone be? So I'm talking about this whole shape, including this imaginary top part that I'm adding. So the large part of that cone, just using my formula with the base area, is pi times the radius squared, so it's pi times 6 squared. And I'm multiplying it by the height, which is 12, so the whole shape would be 12, and dividing it by 3. So that gives me 144 pi centimetre cubed. I'm going to leave my answer in terms of pi because it's more accurate. Okay, so I found the whole shape, but now I just need to chop off this little top bit because it's not there, right? I'm only interested in the blue bit. So let's find the volume of this cone bit on top as well. So my smaller cone, well, it's got a radius of 3, so I'm going to do pi times the radius squared, multiply it by the height of the smaller cone, which is 6, divided by 3. So that gives me 18 pi centimetre cubed. So to find the volume of my blue frustum, all I'm going to do is take my larger volume, and subtract the smaller volume, and that gives me 126 pi centimetre cubed exactly, and I am done. Okay, so something a little bit more tricky that we may be asked. So what if they're asking me to find a missing length in a frustum, like given these other dimensions? So a problem like this, can you think how you could do this? Pause the video if you are feeling confident, but I'm going to explain it now. Okay, so I can think in terms of similar shapes. If you imagine this whole massive cone, including the top part, and if you just imagine this smaller shape on top, these two shapes are similar, meaning that their lengths would share a consistent scale factor. So the height of this smaller cone compared to the big cone, so the whole shape, they'll be linked by some kind of scale factor. So how does 10 link to 15? What do I times 10 by to get 15? To find the scale factor, let's take the bigger length and divide it by the smaller length. So that tells me that my scale factor between the smaller cone and the whole shape, the larger cone, will be 1.5. This is going to help us calculate that missing radius, right? So I have my larger length, and I know that my larger length divided by 1.5 will give me my smaller length, which means that 6 divided by 1.5 gives me 4, which tells me that that missing radius is 4. Okay, so let's read the question. So first of all, we'll find the missing length of the top radius. Well, we've done that. We've got an answer of 4. And now the second part of the question is, we'll hence find the volume of that frustum. Okay, well, all I'm going to do is we'll find my larger cone. So using that formula, pi times the radius squared. The radius is 6 and the height is 15 divided by 3. using a similar strategy to find the volume of the smaller cone, and I'm taking my larger volume, subtracting the smaller volume. So I'm just taking away this bit on top, so I'm just left with that pink purpley shape. Okay, so my final answer is 380 pi over 3 centimeter cubed. I'm just leaving that in its exact form. Okay, so at this point, please could you work your way through question 1 on your worksheet. So you've got A, B, C and D to do, and then once you've done that, come back to the video because I'm going to explain one of the much more challenging problems that we've got today. So work through the first 4 questions and then come back to the video, please. Okay, these are your solutions to question 1. Okay, so let's try a much more challenging one together. So first of all, I'm finding the missing height of the top section of the frustum, and then hence I need to find the volume. So by the height of the top section, we mean this length here. So in maths, if we don't know what something is, what should we call it? Well, we're going to assign a variable to it, so a letter, a piece of algebra. So because it's height, let's just call it h. Alright, the next thing that's going to help me is if I come up with an algebraic expression for this length as well. So if this is h and this is 11, what algebra can I write to represent this length here? Well, it's h plus 11, right? Now, similar to the last one we've done together, we are going to think in terms of similarity. So we have 2 corresponding lengths here. I know that this 6 links to the 9 by a certain scale factor. I know that this h links to the h plus 11 by a certain scale factor. Right, so do you remember how you find the scale factor? Well, we can just take the larger length and divide it by the smaller length. So we could say, well, h plus 11 over h is my scale factor. And I could also say that 9 divided by 6 is my scale factor. These 2 scale factors that are equal, so I'm just putting an equal sign in between them. Now I have an equation to solve. One thing I can do, I can multiply both sides by 6 and both sides by h to just get rid of those fraction parts, so it just looks a little bit nicer. So at this stage I'm going to expand my brackets just to make it look a little bit neater. And now I'm going to solve to find that missing value h. Right, at the moment there are h's on both sides of the equation, so let's subtract 6h from both sides to tidy it up a little bit. So 66 is 3h, 1h will be 22. Okay, so thinking back, what does that actually mean if h is 22? Well, that means that on my diagram, this length here is 22, so what would this larger length be as well? 22 plus 11 gives me 33. Alright, so I've done the first part of the question. I've calculated the missing height, and now I need to find the missing volume. Right, so I've done the hard bit, the second part's a little bit easier. To find the volume of a frustum, remember all I need to do, imagine the whole shape and find the volume of it, and then just take away this little imaginary cone on top. So this large whole shape, so the large cone, it's got a radius of 9 and a height of 33. And then my small shape, it's got a radius of 6 and a height of 22. And I'm just going to leave it in terms of pi to take away my larger shape from the smaller shape. So this gives me 627 pi centimeter cubed exactly, and I am done. Alright guys, so please could you find the rest of your classwork on Google Classroom. All your answers are attached on the worksheet. And as always, please just let me know and get in contact with me on Google Classroom if you need any help. Alright, thanks very much guys, and good luck with the task.